بسم الله الرحمن الرحيم والصلاة والسلام على أشرف الأنبياء والمرسلين. In this video we will explain the three-phase transformer connected in YY connection step up using MATLAB Simulink. First we launch the application and then we go to Simulink. We choose blank model. Let's make it bigger, and then we go to the library and we go to Simscape. From Simscape we choose Power Systems, Specialized Technology, and Fundamental Blocks. From Fundamental Blocks we take the Power Q, which is the most important part in our experiment. Without it our experiment won't run. Again, library, electrical sources, we take the three-phase programmable voltage source, and from fundamental blocks we go to elements, we take the ground and the three-phase transformer. Now we connect the neutral with the ground. Let's make it bigger, and we connect A with A, B with B, C with C. Okay. Again we go to the library. From fundamental blocks, from here we go to measurements and we take voltage measurement. We need 3 of the voltage measurement, so we copy it 3 times. Now we connect each voltage measurement with AB and BC and AC. Let's start A with A, the first one A and B, then B and C, the last one is A. Let's make it this way, A and C. Yes. Now again we need 3 voltage measurement to measure the voltage line before and after the transformer. We'll do the same thing. We connect A, the first one A and B, B and C, the last one A and C. Now again the library. From Simulink we go to from sinks we go and look for sinks. Yes, this one. We take the scope and the screen, which will display the voltage. Let's make it bigger and edit its properties. Double click on it and we go to the setting or configuration. We have 3 voltage measurements, so we have 3 inputs. Our sample time we make it small, 0.00001. Okay, done. We copy it, we paste it here for the 3 voltage measurements. We connect them even here. Okay, so for the display we need something called RMS, which we can find it in the library. From Simscape, Power Systems, Specialized Technology, Fundamental Blocks, and from Control and Measurement we go to Measurements and we take the RMS. We connect it to the screen and we connect it before the scope. Again, we do the same thing for the part which is before the transformer. We copy the display screen and the RMS, connect them, and before the scope. So now we are almost done with the connection, but we need to change the properties for the three-phase voltage source and the transformer. First, let's start with the three-phase. Our input voltage or amplitude is 100, the phase angle is 0, the frequency is 60 Hertz. So we keep it this way, and we go to the transformer. Our connection is Y connection, so we choose Y and Y. Our parameters, we choose the units SI units, and because we have ideal transformer, our experiment is about ideal transformers, so we have no value for the inductance. The last value, as you can see here, is the value for inductance. We make it 0 because our experiment is an ideal transformer, and it's step up. So for the voltage we make it 1, and the winding 2 we make it 2. So as you can see, 1, 2, it's step up. For the magnetization resistance we make it infinity, so we write INF. Even for inductance, the magnetization resistance and magnetization inductance, INF. Apply. Okay. Now I think we are done. So yes, before we run our experiment we need to make this value 0.2 to make our graph clearer. Bismillah, run. Yes, so we go to the scope and double click on it. This is our graph. As you can see here, before the transformer our voltage 100, and after the transformer 200, because it's step up. Now this displays our line voltage, but if you want to display the phase voltage, or you want to know what's the value for the phase voltage, you can use something called divide, which you can find it in Simulink math operations, this block divide. As you know, gentlemen, in the Y connection the voltage line equals root 3 times voltage phase. So if you want to find the value for the voltage phase, we need something called divide, and we need something called constant. Enter. Yes, this one. First we connect the voltage line, and we connect the division part to the constant, and we edit the constant value. Double click on it. We make it square root of 3, SQRT of 3. sorry for that, of 3. Apply and OK. Now we need display to display the value for the phase voltage. Control C and Control V. Let's make it here, and we connect it. Bismillah, we run. I believe we are almost done. This is our first part of the experiment. This is the voltage line, and this is the before the transformer, and this is the voltage line after the transformer, and this is the phase voltage. Now the second part of the experiment is to measure the voltage line and phase if we have Y and delta connection. For Y and delta connection, in delta connection we know that the voltages are equal, so we remove this part, delete, and we go to the transformer, double click on it, parameters, and connection, and the winding 2 we choose delta. OK, and OK, run. Let's check the graph. Yes, this is our graph. So this is our experiment. Thank you for listening. يعطيكم العافية والسلام عليكم.